Welcome to Zoom in Data. In this session, we will discuss Databricks Clusters, which are the computational backbone of the Databricks platform. Clusters provide the resources needed to run notebooks, execute jobs, and process large-scale data efficiently. Understanding cluster types, configurations, scaling, and management is crucial for both practical implementation and interview preparation. Mastery of clusters enables engineers to optimize performance, manage costs, and deploy reliable data pipelines across cloud platforms. Key points covered in this subtopic: types of Databricks clusters and their use cases, cluster configuration, auto-scaling, and termination, best practices for cluster management and monitoring, security, cost optimization, and performance tuning. Subscribe to Zoom in Data to continue structured learning of Databricks concepts. What is a Databricks cluster? A Databricks cluster is a set of computational resources used to run notebooks, jobs, and workflows within Databricks. Clusters consist of driver and worker nodes that work together to execute distributed tasks using Apache Spark. Engineers can configure clusters based on workload size, type, and performance requirements. Clusters enable efficient processing of large datasets while providing flexibility and scalability for various applications. What are the different types of Databricks clusters? Databricks supports interactive clusters for development and collaboration, and job clusters for automated workloads. Interactive clusters remain active for multiple users to run queries and notebooks simultaneously. Job clusters are ephemeral and terminate automatically after executing scheduled jobs to save costs. Choosing the right cluster type ensures optimal resource utilization and cost efficiency. How is an interactive cluster used? Interactive clusters allow real-time collaboration among multiple users on notebooks and dashboards. These clusters support iterative development, testing, and exploratory analysis. Engineers can share resources and libraries across the cluster to maintain consistency. Interactive clusters provide a stable environment for development before moving workflows to production. How is a job cluster used? Job clusters are created specifically for executing scheduled or automated jobs. They are ephemeral and terminate automatically after job completion to reduce costs. Each job cluster can be configured independently for specific tasks, runtime versions, and dependencies. Job clusters ensure predictable, isolated, and reproducible execution of production workloads. What is the role of the driver and worker nodes in a cluster? The driver node coordinates tasks, manages job scheduling, and tracks progress in the cluster. Worker nodes execute the tasks assigned by the driver, handling data processing in parallel. Together, they provide distributed computing capabilities for large-scale data workloads. Understanding the roles of driver and worker nodes is essential for optimizing cluster performance. How does autoscaling work in Databricks clusters? Autoscaling dynamically adjusts the number of worker nodes based on workload demand. When workloads increase, additional workers are added to maintain performance. During idle or low-demand periods, nodes are removed to reduce costs. Autoscaling ensures efficient resource utilization and cost optimization while maintaining performance. What are the key configurations for a cluster? Clusters can be configured with instance type, number of nodes, runtime version, and autoscaling settings. Libraries and dependencies can be installed at the cluster level for consistent execution. Security settings, such as IAM roles, encryption, and network isolation, can also be configured. Proper configuration ensures high performance, reliability, and secure operations. How does a cluster terminate automatically? Clusters can be set to auto-terminate after a period of inactivity to save costs. Auto-termination prevents unnecessary charges when no notebooks or jobs are running. Administrators can configure the time duration for idle clusters before termination. Auto-termination is a key cost control feature in enterprise deployments. How do clusters handle libraries and dependencies? Libraries can be installed at cluster creation or dynamically during runtime. Shared clusters allow libraries to be accessible to all users for consistent results. Dependencies can include Python, R, Scala, Java packages, and custom libraries. Managing libraries properly ensures reproducibility, avoids conflicts, and accelerates development. What is the difference between a single-node and multi-node cluster? Single-node clusters are used for lightweight testing or small datasets and contain only a driver node. Multi-node clusters consist of a driver and multiple worker nodes for distributed data processing. Multi-node clusters provide higher performance for large-scale analytics and machine learning tasks. Choosing the appropriate cluster type balances cost, performance, and resource requirements. How does cluster monitoring work? Databricks provides dashboards to monitor CPU, memory, disk usage, and job progress. Alerts can be configured for failures, high utilization, or performance thresholds. Monitoring helps administrators optimize cluster efficiency and detect bottlenecks. Proactive cluster monitoring improves reliability, reduces downtime, and enhances operational efficiency. How can clusters be shared across users? Shared clusters allow multiple users to run notebooks and queries simultaneously. This is useful for development teams working on the same dataset or project. Shared clusters maintain consistent configurations and libraries across all users. Sharing clusters promotes collaboration while reducing resource duplication. What is a high concurrency cluster? High concurrency clusters allow multiple users to execute concurrent queries efficiently. They use optimized scheduling and resource sharing to handle multiple workloads. Ideal for BI dashboards, shared notebooks, or collaborative analysis. High concurrency clusters improve performance for multi-user access without resource contention. How does cluster scaling impact performance? Proper scaling ensures tasks are distributed efficiently across nodes. Oversized clusters can waste resources and increase costs, while undersized clusters may slow execution. Autoscaling dynamically adjusts node counts based on workload, maintaining optimal performance. Understanding scaling principles helps engineers balance speed, cost, and efficiency. How are clusters secured? Clusters can be configured with IAM roles, network isolation, and encryption at rest and in transit. Users can be granted role-based permissions to control access to compute resources. Security configurations prevent unauthorized access and protect sensitive data. Secure clusters are essential for enterprise compliance and risk management. How do clusters support machine learning workflows? Clusters provide distributed computing for training large-scale ML models. Libraries such as MLLIB, TensorFlow, PyTorch, and scikit-learn can be installed at cluster level. Interactive clusters allow experimentation, while job clusters automate training pipelines. Proper cluster configuration accelerates ML development and ensures reproducible results. What is the role of cluster pools? Cluster pools pre-create idle nodes ready for new clusters, reducing startup time. Pools optimize resource usage by reusing idle nodes instead of provisioning new ones each time. They improve performance for frequently created ephemeral clusters. Cluster pools help reduce costs and speed up cluster availability. How is cluster cost managed? Costs are managed using auto-scaling, auto-termination, and instance type selection. Spot instances or preemptible VMs can be used to reduce compute charges. Monitoring usage and setting budgets ensures cost-effective operations. Efficient cluster management balances performance and operational expenses. What are best practices for cluster management? Use auto-scaling and auto-termination to optimize cost and performance. Separate clusters for development, testing, and production workloads. Monitor utilization and adjust configurations based on workload patterns. Maintain libraries and dependencies consistently across clusters for reproducibility. How do clusters handle streaming workloads? Clusters run structured streaming jobs for real-time data processing. Worker nodes process partitions of streaming data in parallel for scalability. Checkpoints and fault tolerance ensure reliable data ingestion. Streaming clusters provide continuous, high-throughput processing for live pipelines. How is cluster performance optimized? Choose appropriate instance types, number of nodes, and auto-scaling settings based on workload. Monitor CPU, memory, and disk utilization to identify bottlenecks. Use high concurrency or GPU-enabled clusters for specialized tasks. Optimized performance ensures faster execution and efficient resource use. What is the difference between standard and high concurrency clusters? Standard clusters are dedicated to a single user or job, optimized for interactive development. High concurrency clusters allow multiple users to share resources efficiently. High concurrency clusters use optimized scheduling to prevent task interference. Selecting the right cluster type depends on workload and user requirements. How are cluster logs and metrics used? Logs track job execution, cluster events, and system errors for troubleshooting. Metrics provide insights into performance, utilization, and efficiency. Administrators can analyze logs to optimize resource allocation and detect issues. Using logs and metrics improves reliability, cost control, and operational insights. How does cluster lifecycle management work? Databricks automates cluster creation, scaling, and termination. Cluster policies define allowed configurations and enforce governance. Lifecycle management reduces manual intervention and improves consistency. Proper lifecycle management ensures cost efficiency, security, and performance. Why is understanding Databricks clusters critical? Clusters are the core computational units for running all workloads in Databricks. Knowledge of cluster types, configurations, and management ensures efficient and cost-effective operations. Proper cluster management is essential for performance, reliability, and secure execution of data pipelines. Thank you for watching Zoom in Data. If you found this video helpful, like, share, subscribe. More Databricks interview and tutorial videos coming soon. Stay connected and keep learning with Zoom in Data.